Before we begin Unit 24, here is the answer to the Unit 23 question. The best answer is choice C.
The major ambient or outdoor air pollutant categories are carbon oxides, nitrogen oxides, sulfur oxides, particulates, ozone, and volatile organic compounds. The gaseous phase of water, referred to as water vapor, is an essential part of the hydrologic cycle and not considered an air pollutant. Unit 24. Let's clear the air.
Most of us spend the majority of our lives indoors. Whether it's at work, at home, or in the car, most of the air we breathe comes from inside some structure.
Unfortunately, compared to ambient air, indoor air pollution causes the most serious health problems.
Not to scare you, but did you know that the air fresheners in your bathrooms contain para-dichlorobenzene? The dry-cleaned clothing hanging in your closets emits tetrachloroethylene, and if you have an underground basement, there's a good chance it contains radon.
These substances can cause cancer, liver damage, and lung disease.
The truth is that our home is filled with many sources of air pollution, but don't be that alarmed. Remember, it's all about risk.
The question is, what is acceptable risk when it comes to indoor air pollution?
Air pollution is detected and measured using a variety of methods.
Pollutant levels are usually expressed in a fraction of contaminant to sample of air.
For example, if there are 10 molecules of formaldehyde in 1 million molecules of air, the concentration is reported as 10 parts per million formaldehyde, or 10 ppm formaldehyde.
The situation in which indoor air pollution conditions reach unsafe levels that may cause harm is referred to as sick building syndrome.
Indoor air pollution specialists work to detect and measure pollutant levels, evaluate emission sources, and mitigate problems in order to improve the health and well-being of building occupants.
Sometimes the solutions can be as simple as replacing the pollution sources with equally effective substitute products. Other times, it's not that easy.
Asbestos is a flame-retardant material that was once commonly used in buildings, clothing, and other everyday items.
Asbestos is made of very small fibers that, when inhaled, act like microscopic fishhooks that the lungs are unable to expel.
Many workers that had been exposed to asbestos became afflicted with asbestosis, a disease that scars the tissues of the lungs.
Individuals suffering from asbestosis often experience shortness of breath and become high-risk candidates for developing mesothelioma, a type of cancer that causes tumors in the lining of the lungs.
Symptoms of mesothelioma can take many years after exposure to develop.
By removing the asbestos or rendering it in a way that the fibers were no longer able to become airborne, the problem was successfully mitigated.
Unfortunately, prior to the scientific linkage of this material to the disease, many people have become sick or died from this illness.
You might think that a good way to solve the air pollution problem is for the government to pass laws that set limits for harmful contaminants.
Since the 1970s, the United States has passed many such laws that have resulted in maximum contaminant levels, or MCLs, for both indoor and ambient air, especially for the most hazardous substances.
The National Institute of Occupational Safety and Health, NIOSH, sets standards for indoor air contaminants.
The Clean Air Act requires the United States Environmental Protection Agency to enforce the National Ambient Air Quality Standards that sets limits for outdoor air pollutants.
There is a catch. The more stringent air pollution regulations are, the more economic strain is placed on companies trying to compete locally, nationally, or in the world market.
As a result, there remains much debate over the appropriateness of the allowable levels.
In addition, should people decide that their economic priorities outweigh their concern for health and well-being, politicians and legislators may move to lessen or remove environmental laws, as well as the scope and power of enforcement agencies.
Preventing pollution before it happens is obviously the most effective solution to the problem.
Factories, power plants, and other companies can make engineering changes to existing designs or implement new operational procedures to reduce emissions.
However, pollution prevention requires companies and organizations to alter their operations, and that may necessitate a large financial investment.
Unless pressure is put on elected officials to enact appropriate regulations, pollution prevention may not have a significant impact on either the indoor or ambient air problem.
Even if air pollution cannot be prevented, it can be removed before going up the smokestack or into the room.
Particles can be removed using what are called high-efficiency particulate arrestants, or HEPA filtration systems. Similar to vacuum cleaners, these devices use filters to physically screen out the pollutant particles.
Devices known as electrostatic precipitators can also remove particulate air contaminants by charging them electrically and then collecting them on oppositely charged plates.
Since gases can pass right through filters and normally cannot be charged, HEPA or electrostatic systems do not work when dealing with VOCs or other gaseous contaminants.
Instead, chemicals are used that adsorb or chemically combine with the pollutants in devices called scrubbers. There are both wet, using water, and dry, using chemicals, systems.
The good news is that all of these particulate and gas cleaning systems can be very effective, removing high percentages of contaminants.
The two major drawbacks are the cost of installation and the fact that once removed from the air, we now have either a solid or liquid waste that will need to be disposed of properly.
In addition to regulation, prevention, and removal, there are many other ingenious strategies that people have implemented in order to combat the air pollution problem.
One very interesting concept that helps states meet their national ambient air quality standard goals is what is known as emissions trading or cap-and-trade programs, through which companies such as power plants and factories can buy and trade the rights to pollute.
This program puts the economy to work for the environment, and as long as the overall emissions remain below the allowable standards, the states can remain in compliance.
In the home, people can choose to avoid processes that create smoke, buy furniture and building materials specially prepared to minimize emissions of harmful chemicals, and use household products that are less polluting.
When it comes to motor vehicle emissions, there is the common sense approach that includes walking, biking, or using mass transit, improving fuel efficiency in motor vehicles, and simply getting older cars off the road.
In preparation for the future, environmental scientists are constantly developing innovative methods of converting processes that rely on fossil fuels to those that can be just as effective using renewable resources.
Keep in mind that air pollution is not a localized issue. We live in a fishbowl filled with air instead of water.
Anything we put into the air affects anyone or anything that may eventually come in contact with it.
As air currents in the atmosphere are in constant motion, and air masses have no set boundaries or borderlines, we must consider air pollution a global problem and work together as one large community if we are truly to create a world in which everyone has access to clean air.
Take a deep breath and think about that. Here's your question for Unit 24.
The best solution to handling any indoor air pollutant is
Choice A, the use of HEPA filtration systems.
Choice B, the use of electrostatic precipitators.
Choice C, the use of wet and/or dry scrubbers.
Or Choice D, the implementation of pollution prevention strategies.
The answer and explanation are provided at the beginning of Unit 25.